So last video we talked about this technique of finding solutions to differential equations by separating the variables. And we went through one quick example, but I just wanted to talk a little bit more about when we can and can't use this technique. And it sounds a little silly, but we can use the technique of separation of variables when we can separate the variables. So if we have a differential equation, in this case a first order differential equation, that's of the form something involving y's, so I'm going to call this g of y, just meaning like some function of y's times some function of x's, this is the situation when we can use a separation of variables. We can do that the manipulation we did last time where we divided the y part over and we multiplied the dx over, and then we had all of x on one side and all of y on the other, and we could go from there. So some situations where we can't use something like this, if our differential equation, and I'm going to switch from dy dx notation to y prime notation just to get in the habit of switching back and forth between them, but if we have something like sine of x plus y, so this is a perfectly valid differential equation, and we can solve it using something like Euler's method or the slope fields or some techniques we'll learn in the future. But we can't do separation of variables for this because there's no way to isolate the x and the y's in the same way. You might say, it's like, well, what if we took the inverse sign? So if we took the inverse sign, and I'm going to switch back to our dy dx notation. So dy dx, if we took the inverse sign of both sides, certainly a valid algebraic thing that we can do, but now we can't separate the dy and dx part. We can't multiply over a dy dx. There's no rule for distributing this. This is just a situation that we can't use separation of variables because we can't separate the variables. The one last thing I wanted to point out was that we typically, when we're talking about these as functions, think about it as dy dx. But in practice, we're often going to be talking about, so most of the rest of the semester, we're going to be talking about applications of differential equations. And so depending on the context, maybe we're talking about how the pressure changes over time, and we're talking about dp dt. These are just different variable names. We're going to see this show up every now and then, but this is the exact same idea. If we have dp dt of equals p over t, we can solve this by going through by isolating each of the variables on their respective sides and going from there.